Hi, C Sharp and .NET developers. Welcome to a new episode of A Dash of .NET. And I believe you all are into C Sharp and .NET. I suppose, right? Because that is what the show is about. In this episode of A Dash of .NET, we're going to learn on how you can infuse machine learning, data science, and all that into your C Sharp and .NET applications. The world is moving towards AI and data science, and this is a must video for everyone. And to talk about today's topic, we're joined by Sam Nasr. He's a senior software engineer. He's been a Microsoft MVP since 2013, very long. He's an MCSA, MCAD, MCTS, and whatnot. So without any further ado, let's bring Sam in. Hi, Sam. Welcome to the
Good.
show.
Thank you, Simon. Good to be here.
Yeah, those were a lot of certifications. I kind of fumbled while reading it.
Yeah, indeed. But very grateful to have them.
Yeah, thanks, Sam. Thanks for doing it. I'm going to let you take the stage because I know you have a lot to cover, and I'm really excited for this adding ML to .NET applications. We all are C# .NET developers, and I cannot wait for the session. It's all you now.
Excellent. Thank you. So this is one of my favorite topics to talk about, primarily because we see a lot of machine learning and AI that is penetrating the marketplace in a variety of different ways. And a lot of us, regardless which type of enterprise we work in, we have a lot of data. So what is it that we can do to utilize that data and be able to build a machine learning model out of it? So let's dive right into it. First of all, let's start with an overview. So with ML.NET, what that's going to be doing, it's going to be using a model for providing machine learning to .NET applications. So we're going to have an existing .NET application, and using ML.NET, we're going to be able to add machine learning capabilities to it. So these machine learning capabilities or scenarios, they're available in both online as well as offline. And I'll talk more about that as we step through the demo. Essentially, what it's doing is it's using patterns of data to make predictions, as opposed to a developer having to specify explicit logic or a formula to be able to come up with the results. So we just simply feed it the data, and it learns from it, and then it's able to make predictions going forward. So essentially, the ML.NET model, it's an object that contains the transformations, or the formula, if you will, for being able to take an input value and come up with an output value. For example, I can feed it a set of home prices over the last 3 years for a specific zip code. And then if I put in a prediction saying how much is it for a 2,000 square foot home, then it will come back and it will say it's this price based on the historical data. So some other transformations or prediction types that we can utilize, we have classification and categorization, which is essentially taking the data that's inputted and classifying it into one of two categories. We can also look at it in a regression, meaning that we have a sliding scale, such as home prices or other scenarios where it's inversely or proportional to another value. We can also utilize it to do anomaly detection. So if anything is out of the norm, we can use machine learning to be able to point that out. Another one of my favorites is recommendations. So we've all used a website called Amazon.com. And every time you make a purchase, it always recommends something else that will go along with it, right? And so we can use that machine learning model to make those recommendations as well. In addition, there's time series sequential data where it learns off of historical data. And we can also use it to do image classification, where I feed it an image and it will classify it as whether it's a fruit or a vegetable, depending on how I train the model. So some of the examples of linear regression, we see that on the left, we have a proportional scale where it could be an example of home prices rising over the years. And then there's other examples of inversely proportional, as you see over on the right-hand side, where we have the HDL, or the good cholesterol. It's inversely proportional to the BMI, or the body mass index. So the heavier the weight of a person is, chances are they're going to have a lower good cholesterol level. And so that is an inverse proportional relationship. And there you see with the triangles that are listed on the graph, these are outliers where you have some extreme cases. But for the most part, it's essentially a inversely proportional linear regression. So some terminology that we need to cover right off the bat. You'll hear the word feature. What a feature is, it's an input for a machine learning model. So this could be the size of the home, it could be the mileage on a car, it could be some other input value that I'm training it on. The label is the output value that I'm getting from the machine learning model. So for example, if I'm feeding it in the size of the home, I'm getting the price for that home. Likewise, if I put in the mileage for a specific vehicle, it will give me the current market price for that vehicle based on the data that I trained it on. So essentially, we have input and output. Now, what goes in between is the transform. That is the type of prediction that is going to be learning on the data that we feed it, and then it will be able to handle the feature or input going in, and then be able to produce a label or an output going out. So that's some of the basic terminology. Now, what does the model development look like? How do we get to a stage where we can take data and be able to make a prediction out of it? So looking at this image, we see that we start off at the very top where we collect and load the data, because that is crucial for machine learning. Then we create the pipeline using the append method, and then we train the model using the fit method. Afterwards, we then evaluate the model to see is it in fact working according to what we have trained it on. So I would give it a sample value for a home price or the mileage of a vehicle, and then I would get the output value, and then I can determine whether that's correct or not. If it's not, then the cycle continues to repeat again, where I'm feeding it more data to train it more. And again, I use the append method, the fit method to train it, and then evaluate it. Once I get to a point where I'm satisfied with that model and the values that it's producing using the evaluate method, then I can move on to the lower portion of the graph where I am saving the model using the save method. So now I created a model or a transform, and now I'm ready to use it. After I use the save method, what it does is it saves it as a .zip file. Then I can take it into another project in my solution, be able to load it using the load method, and then I can make predictions, as you might have guessed, using the predict method, as we see at the bottom of the slide. Okay, so essentially it's a cyclical process. Once I'm comfortable with the values that it's producing, then I can save the model, load it, and be able to make predictions going forward. Now, let's get into a level of detail. So in order to be able to get to that point, I need to have some prerequisites on my machine. So first of all, I would need Visual Studio, and I would need to identify that I need the desktop development environment, and more specifically, as you see circled in the pane on the right, ML.NET Model Builder. So once those are selected, now I'm able to utilize machine learning.NET in my project. And I can do this in one of three ways. I can use the UI, where I simply right-click on the specific project, select Add, and then I'll see machine learning popping up as one of the items that I can add in the context menu. I can also do it programmatically by adding the NuGet package for Microsoft.ml. Or if I'm so inclined and I am very comfortable with the command line, I can use the command line interface to be able to add machine learning into my solution. And so with that, like all things, it's better explained through a demo. So let's jump into it. And what I did here is I created a very basic project. So this is a console application, and I selected all the defaults. I called it the dash demo for the dash of .NET. And again, I haven't changed anything. I just simply selected all the defaults. It's bare bones, as you see over in my Solution Explorer. So now, how do I get started by adding a ML.NET project to it? So I would right-click on the project, select Add, and there I see the machine learning model as one of the menu options. And again, this is available because I went through the prerequisites of installing the desktop environment in my Visual Studio, and I was sure to select the machine learning model. So once I go ahead and click that, now it's going to walk me through a couple things on the menu. And so it's asking me, what should we call this project? Let's go with ML model 1.mbconfig. I'll accept the defaults, select Add. It'll take a minute to chug through and add that in. And now it's going to run me through a GUI interface where I'm going to select the scenario and identify the various factors. So if you recall, we said that we can use machine learning .NET to be able to do classification, regression, value prediction, a variety of different things. So these are all the different scenarios that are available to me. And as you notice, in the lower right-hand corner of each one, it specifies that it can be done locally. And in some cases, I can use it locally, or I can utilize the capabilities of Azure so that I can utilize some heavy-duty computing power. And in some cases, like object detection, it's only available in Azure. So for this specific scenario, I'm going to do data classification, which is going to select one of two categories depending on the input that I feed it in. And so it's giving me a summary of my training environment, that it's going to be on my local CPU. This is the type of environment that I have. And next, I'll move on to the next step. And here I need to specify the data. So I have a file, and we'll point to that in just a second. If we go over into the data, you'll see that I have a file called Yelp label.txt. Let's take a look and see what that data looks like. So this is nothing more than a flat text file, as you can tell. And basically, this is a dump of a set of comments that were retrieved off of Yelp for a specific pizza restaurant. And so the comments are classified as either 1 or 0, 1 being positive and 0 being negative. So you see comments like, wow, love this place, and that is a positive comment. Crust is not good, obviously that's a negative comment. And so on and so forth. And as you see, I have approximately 1,000 data items here that I can use. So we'll go ahead and select that file. And as it's loading it, it is now identifying the data. And the next thing it's going to ask me is, which column do I want to use to be able to predict the value? So this will be my label. And if you recall, feature is the input, label is the output. So looking at the sample of my data, it's giving me a preview of the first 10 rows. And I want to be able to use column 1 as my label. And so with that, I'll go into the dropdown. And let's go over here. So we have data classification. All right, so there I specified my file. And then I'm going to specify column 1 as opposed to column 0. So column 1 is my label or my output. Next step is it's going to ask me, how much time do I want to spend training it? So think of training as if you're training for lack of a better word, or educating a 3-year-old, right? You're showing them what is the right thing to say and what is the wrong thing to say. And so it's the same thing here. And so with all the different comments that I have, I'm going to show it which ones are positive and which ones are negative. And so I'm going to select 10 seconds for starters. And I'll say train again, and it will run through it. And as it's running through it, you'll notice in the lower window or the output window, it's going through a variety of different trainers, as we see here, within those 10 seconds. And it's cycling through them, trying to see which one's a good fit. Oh, it says not my day. One error after the other. All right, let's try that again. So train again. Okay, so we trained it for 10 seconds. It ran through a variety of different trainers down below. And then gave us some data as far as the accuracy that was produced. And then the training results, as it shows us here, the best accuracy is 0.6911. The best model that it found for training was the Fast3 OVA. And so if we're satisfied with those results, then we can move on to the next step. If we're not, we can just simply increase the training time. So we'll set this to, let's go 20 seconds, and we'll do training again. And let me expand the window at the bottom. And then you'll see that it's still continuing to cycle through for the specific training time of 20 seconds. It's going to cycle through a variety of different trainers to see which one will produce the best results on the given data. And so if you recall, the first time we trained it for 10 seconds, the results were 0.69, I believe. But now, because we boosted it up another 10 seconds, it gave us better results of 0.70, or actually, if you round it, it's 0.71. So obviously, our accuracy improved as we gave it more time to train. So if you recall from the diagram that I showed earlier, we collect the data, we create the pipeline, we train it, and then the next step is to evaluate it. And that's what we see over on the left-hand side. So when we click next step, it will take us to evaluating the model. So if I pass in a value that says crust is not good as my input, what is that prediction going to be? So it'll chuck through the model that it just created, and it should produce a result saying that this is a negative comment. And as we wait for the results, you'll see that it says this was a negative comment or a result of 0 with a confidence of 76%. For the sake of time, if I can just move forward, but if I'm not satisfied with these results, I want higher confidence scores, then I would, again, go back to the training process and then train it for a longer period of time, giving it more data. But since 76% is pretty reasonable, I will move forward. And now it's asking me, how do you want to be able to consume this model that we just created? So now that we're satisfied with the results, it's ready to save it off, and we can incorporate that into another project within our solution. And I can do that in a variety of ways. I can utilize the code, and it's giving me a code snippet up in the top window. I can also add it to the solution as another console application, or I can add it as a web API to my solution. So for the sake of simplicity, let's select console application, add it to the solution. And so for this solution, you'll notice that I already have one that's pre-existing called Model 1 Console App. But let's go ahead and create that new solution. So let's go over to consume. Now we're ready to incorporate that. And we'll do the console application, add the solution. We'll call it ML Model 1 Console App 2. We'll add that to the solution, and then we'll see what's going on the back end. So we'll give it a minute to run through what it needs to do. So what I'm expecting is it's going to create a third Console App 2, and it's going to be a console application. And there it is. So if we take a closer look at that, we'll see that it's a console application, and like all console apps, there's a program.cs that's included. So this is all auto-generated code by the ML.NET model builder. And then we'll see that we have sample text or sample data where it says crust is not good. And essentially, this is the first row of the data that it took from the file that we specified, and it's going to pass it in as a prediction. And then in the end, it's going to make the prediction and then be able to produce that in the output using the console.write line. So if we run through that second application, it'll take just a minute to spin up. And there's my console window. And so it's going to automatically pass in the crust is not good phrase, and then it'll produce the results on the screen for us. And like all good things, it's worth the wait. So it's just a matter of seconds before it compiles, runs, and then produces the results. As we see here, going through the program.cs, it generated the crust is not good as a starting phrase. It produced the results on the output window, and it shows us that this is a negative comment. And so to be more specific, if we look at the code, we're using this ML Model 1. What ML Model 1 is, it's the model that is saved off. And so that, in a nutshell, is how we're able to utilize machine learning.net within an existing .NET application. We trained it on some existing data, and then we're able to make predictions out of it. And so some concluding slides. So the time to train, this is roughly a rule of thumb depending on the amount of data that you have. But typically, the more time you give it, the and more data you give it, the better the results will be. And so that dovetails into the next question: how do we improve performance? As mentioned, giving it more data, but not just data. It needs to be clean, meaningful data. For example, I gave a sample scenario of home prices where the price is related to the square footage, but obviously with a home price, it's related to a lot more than just the square footage. You have the area, you have amenities within the home, number of bedrooms, number of bathrooms, the zip code that it's in, variety of other factors, whether it's a fenced-in backyard, a swimming pool, so on and so forth. So there's a lot of other factors that influence the price of the home. And so that's what we mean when we say that we need data with context. So we need to scrub the data, make sure that it is clean in the sense of there's no duplicate values, there's no erroneous values, there's no outliers that don't belong there. But more importantly, we need to give it context of other things that could affect the price of that home. In addition, we could use a method called cross-validation, which is basically a technique that splits the data into several partitions, and we're able to do machine learning on those different partitions, and then the result from those different partitions is then gathered, and it's a more effective way of producing a more accurate model. Also, trying different algorithms. As you had seen, we walked through a variety of different algorithms or trainers, and we were able to come up with the best result, all thanks to ML.NET. It did all that for us behind the scenes. All right. So as a recap, what we did was we took an existing .NET application, or in my case, it was a very basic bare bones console app. We pointed it to create a new ML.NET model builder. We specified the file. We specified what's the training column that we need to specify, we specified the column, which is going to be our feature, and then the column, which is our label. And then we're able to produce results or a prediction model out of it. And then we tested that using the evaluate method. And then we were able to produce a final product and be able to make predictions going forward. And so hope that was helpful. If you have any questions or comments, you can always reach out to me later. My contact information, it's available on Linktree/Sam Nasr. In addition, you can always email me, snasr@nistechnologies.com. My Twitter handle is @SamNasr. You can also find my blog at samnasr.blogspot.com. And lastly, I invite you to connect with me on LinkedIn if we're not already connected. And so with that, thanks for having me. And I certainly hope to hear from you. I've had several people reach out to me starting their ML.NET project, and I invite more people to do so. So looking forward to hearing from you. And thanks for having me, Simon.
That was a great presentation, Sam. I think not just for C# or .NET developers, this can be a crash course for anyone who wants to get started with machine learning, because you covered the basics of machine learning, and then you showed a very important algorithm that is linear regression, and then you had a demo, and of course, a demo without the demo daemon is not the complete demo. Right. And I personally like the slides where you talked about the rule of thumb. I've never seen that, but so I'm gonna take a reference from that slide. Thank you so much, Sam. That was absolutely great session. Everyone, you can reach out to Sam on these details, and you can also find the details in the video description. I'll see you in the next episode of A Dash of .NET. Until then, take good care of yourself and see you soon. Thank you, Sam.
Thank you.